Welcome to the Math 1, Unit 8, Lesson 4 summary video, Comparing Methods. This lesson is a practice understanding task which takes concepts you've been working on and applies them to new situations. The purpose of this lesson is to introduce the zero product property, practice factoring and solving quadratic equations, and provide mathematical justification of these steps. So prior to this unit, we only knew how to solve algebraic equations by using inverse operations and the properties of equality. So using those inverse operations applied to both sides, isolating the variable, and then we would get the solution. So in the last couple of lessons, we have been learning how to factor expressions, algebraic expressions. And so we're going to look at this one equation and how we can solve it using the traditional inverse operations method versus the factoring method, which is what we've been looking at in the last couple lessons. So if we use our traditional inverse operations, we know that we would need to add 25 to both sides of the equation. And this would equal 0, negative 25 plus 25. So on the left side of the equation, we'd be left with x squared equals 25. And then we know that we still need to get x by itself, and so the inverse of squaring would be to take the square root of x squared. And we would have to take the square root also of 25. And so the square root of x squared is x, and the square root of 25 we know is 5, but can also be, we can multiply 5 times 5 to get 25, but we can also square negative 5. So it could be plus or minus 5. So we can multiply negative 5 times negative 5 to get 25. When we look at factoring this, we're looking for those binomial factors, and so we're saying we know that the first terms have to multiply together to give me x squared, so that would be x times x. And we know that the last two terms, here and here, have to multiply together to give me 25. And so that would have to be positive 5 and negative 5. And we know that the middle term, the x term, the b term of our trinomial that we've been looking at, we get by multiplying the outside terms, negative 5x, and the inside terms, 5x. And when we add those together, we get our middle term of our trinomials that we've been looking at. Well, negative 5x plus 5x would give me no x's, which is why there's no x term here. We just have our x squared term and our constant term, or our a term and our c term, but no b term here. And so what we know is that when we multiply these two factors together, it has to equal 0. So that tells me that either the first factor has to equal 0 or the second factor has to equal 0, or both possibly. But one of them has to be 0 in order to get a product of 0. So I have to multiply something by 0 to get 0. So what I can do is I can set each of these equal to 0 and then solve for x. And mathematically, I know I can do that because if I were going to isolate this first factor, I would want to divide this whole side by the second factor, by the x minus 5. And so that would equal 1 when I simplify this, and I'd be left with x plus 5 equals, and if I divided this side by x minus 5, I'd have to divide this side by x minus 5. And 0 divided by x minus 5 gives me 0. So I know that I could set x plus 5 equal to 0 and solve for x. I can also do the same thing using the other factor. So instead of dividing both sides by x minus 5, I can divide both sides by x plus 5. And then these would equal 1. Their quotient would be 1. And I would do the same thing here, x plus 5. And so I'd be left with x minus 5 equals 0 divided by anything is 0. So I'd be left with this. So that's how we know mathematically that we can set each of the factors equal to 0 and then solve for them to find the value of each one. So I'm going to write x plus 5 equals 0 and x minus 5 equals 0. And now I'm going to use my inverse operations on each of these to solve for 0. So I'm going to subtract 5 from both sides, and I'm left with x equals negative 5. And in this one, I'm going to add 5 to both sides, and I'm left with x equals 5. So again, I have x could be negative 5 or positive 5, which is the same that I got using the traditional inverse operations method. This process here is called the zero product property. And so this is the property that we're using to be able to set each of my factors equal to 0. I know that the product of these factors is 0, therefore I know that one of the factors must be 0. So that's the zero product property. Let's look at another example. So here, if we're using that traditional inverse operations, we know that we need to combine our like terms, so we're going to add 21 to both sides of the equation. And that equals 0, so we're left with x squared on this side, and on this side we're left with 121, and we're going to take the square root of both sides. And we know the square root of 121 is 11, and the square root of x squared is x, and we know that it could be positive or negative 11. On this one, we need to actually move the 100 to the other side of the equation using inverse operations. So we've got 100 over here. We need to get rid of it, so we're going to take it away. So we're going to take away 100 or subtract 100 from both sides of the equation. That leaves me with 0 on this side. And on this side, I have x squared minus 121. And I'm going to factor this. And I have x times x to give me the x squared. And the numbers that I multiply together to give me negative 121 would be positive 11 and negative 11. And again, I have no middle term here because when I multiply my outside terms, I get negative 11x, and when I multiply my inside terms, I get positive 11x. And when I combine those, I have no x's, therefore I have no middle term. I'm going to use that zero product property to set each of my factors equal to 0, and then I will solve for x, and in this one I get x could be negative 11, and on this side I get x could be positive 11. And so again, we get the same solutions for x using either method. In the next section of the lesson, you're asked to determine which method you would choose to solve each equation and why, and then actually solve it. And so we're going to look at and see if we can, we're going to look at a couple of different problems. This first problem, if we were going to try to solve this using inverse operations, we would want to get all of our terms with the variable on one side and get our constants on the other. But what I first notice is that I have a term with a variable to the power of 1 and a term with a variable to the power of 2. And so there's no way for me to use inverse operations to both sides to isolate that variable. So when I have equations with variables to different degrees, I'm going to have to use factoring. So in order to factor this, I need to get all of my terms on one side. So I'm going to subtract this 40x from both sides, and I'm going to add the 100 to both sides. So I'm going to subtract this 40x and add the 100. And on this side, I'm going to do the same thing, minus 40x and plus 100. And so that will make this side equal to 0, and this side will be 4x squared minus 40x plus 100. And now I notice that they have common factors, and so I can divide each of these terms by their greatest common factor, which would be 4. So I'm going to factor out a 4, and I'll be left with x squared. Negative 40x divided by 4 would be negative 10x, and 100 divided by 4 would be 25. And so I'm looking for my factors that would give me that trinomial. I know my first terms have to be x because they have to multiply together to give me x squared. I know my last terms have to multiply together to give me 25, but I notice that they have to add together to give me a negative 10. So the only numbers that I can multiply together to give me 25 are 25 and 1, and 5 and 5, and negative 5 and negative 5. Well, if I use 25 and 1, then when I multiply the 25 times the x and the 1 times the x and add those together, that won't give me negative 10x. If I use positive 5s, when I multiply the positive 5 times the x here, I get 5x. Positive 5 times the x here, I get 5x. That will give me a positive 10x. So I know that it has to be negative 5 and negative 5. So that when I multiply these two, I get negative 5x. When I multiply these two, I get negative 5x. And when I add them together, I get negative 10x. I'm going to set these equal to 0. And because these are the same factors, I only need to do that one time because I'm going to get the same answer. And so I'm adding 5 to both sides. And I end up with x equals 5. And so that is my solution. And if we look at this problem, we can factor out a 10. The greatest common factor of both terms is 10. And so when I factor out that 10, I'm left with x. 10x divided by 10 is just x, and negative 20 divided by 10 is negative 2. That equals 0. And so now I can use my zero product property, set that equal to 0, add 2 to both sides, and I'm left with x equals 2. So that's using the inverse, or excuse me, using the factoring. I can also use inverse operations on this one. So this is one where I could use either approach. And I'm dividing both sides by 10. And I end up with x equals 2 again. So some of them you will only be able to factor. Some of them you'll be able to use inverse operations or factoring. Let's look at one last example. If we were to try to solve this using inverse operations, we would need to first add the 20x to both sides of the equation, and we would end up with 10x squared equals 20x. And so what most people would do is they would try to divide both sides by 10x. Well, we can't divide by x because we don't know what the value of x is. And because x could be any value, including 0, if x were 0, we know that we can't divide numbers by 0. And for that reason alone, we can't use inverse operations when solving this type of problem. Additionally, we know that we would need to eventually take the square root, and so if we're not taking the square root of this x squared and thereby taking the square root of the other side, we would be missing out on one of the numbers. So we would only end up with the positive number or the negative number when we're using division instead of taking the square root of both sides.